try to listen, always whenever I start recording. At the end, it looks like the battery dies out or something. Yeah, so most probably getting new batteries just to make sure that will work. So let's go ahead. Okay. Well, in this chapter, we'll talk about technically how the the materials that we use in the office, like to replace a missing tooth for a crown or a bridge, inlay or onlay, a partial denture, are made. How actually these are made, and technically the metals that we use, because a lot of them are used from metals, done from metals, and what are the different metals that we use, and some properties for each type of metal that we use. So it's a small chapter, I think, generally. So I guess a good an intro to this is to think about how the dental prosthesis, and when we say prosthetics, anything that replace a natural body part is a prosthetic, right? Like a prosthetic leg or arm. And same thing for dentistry, we say prosthetic, a dental prosthetic. We even have a part of dentistry or specialty for prosthodontics, right? And those are the dentists that usually do complete dentures, partial dentures. They do implants, crowns and bridges as well, same thing, but they're usually more on the complete and partial dentures where they do a full mouth reconstruction, something like that. So when we think about how these crowns are actually made, like if anything that is not regular filling, when we say, we have a filling composite or amalgam, but other than that, like a crown that is a full gold crown or a PFM, you know what PFM is, right? Fused to metal. Yes, that was with your, that's part of your charting, right? Yes, and you have all ceramic crowns. So how are these made? We know we take the impression, right? We prepare the tooth, we take the impression, we know all of these parts, and then we send it to the lab. So what is going on in the lab? How are these done? This is what we're going to talk a little bit about and understand, so we can get a good introduction to the materials that are used to make that. So if we want to kind of think about the main method that any of the prosthodontics, dental prosthodontics are used or done, they can be milled out of block. And I think I showed you before a video where they mill, a tooth. You take a 3D picture of the tooth instead of an impression, or you take an impression, pour a model, and the lab will take a 3D image of the model, and they have a block, and the block will be milled down to make the shape of the crown, right? That is one thing. 3D printing is coming on as well, strong. So nowadays we also have a machine that 3D prints a dental prosthesis, like even a complete denture or a partial denture or even metal parts. So there are 3D printers for metal dental prosthesis. Layered, so these are the newer versions of things that are done. And layered is the one that used to be, most of the time used, and that's how the porcelain is made, porcelain fused to crown. So they actually have a tooth, and they start putting layers on it of the material, and they build it up in the lab with the porcelain, with the actual material of porcelain, and they fire it up in an oven, and then that will make the crown. And then this method that we will talk about more, which is the lost wax technique, and that was most of the crowns used to be made of a lot of partial dentures they're made of. This is the other technique where we build the actual shape of the crown with wax first, and then we put it in an oven. That oven is too hot, it will evaporate the wax in it, that we made. And then we inject metal instead of that wax to make the actual model. So I know it doesn't make a lot of sense, and that's why we have a video to see. So just to understand that, these are the main method of making a prosthetic, a dental prosthetic. Again, it can be milled we can 3D print it, and we can layer it as porcelain, and then we can do the wax technique. So let's take a look at that lost wax technique, because I think this would relate much more to what we are going to talk about, because we're talking about these metals that are used in the lost wax technique. So it's very important for us to understand that. So let's see here. Something is going on. Okay. So I think, for example, this video. Let's take a look. So this is a crown that is made out of wax. Okay, this is an impression. We took an impression. Excuse me. This patient has a molar that needs to be crowned. We need to make a crown for this molar. They made the wax part. They made the crown out of wax, right? They build it up all together, and then you can see they put something which we call a sprue, and you'll see why is this placed in there. Technically, all of this that you're looking at is wax again. So we took the impression, sent it to the lab. The lab technician made a wax version of the tooth. The best taxability and least porosity is produced by a tooth former, not foundation. Sensitive to 4 months of years. The turkey cannot be good to a heart, or foundation. Sensitive to 4 months of years. Now you see this is a die. Remember, we call these dies, which are portions that would we use. This is what the lab technician will make out of the cast that we send them. They will cut it into parts, and they make dies out of it. And the die is that just like the 1-2 that we need to work on, which you can take out of the cast, so you can work on it separately. So now they're going to remove the crown out of it, because again, this is just, see, that is all wax crown. They're connecting it to something that will make like a, I don't know, what do you call that? Like, what do you call it? A cylinder, not a cylinder, a cone. You'll see this will make a cone shape so we can put the metal in through. So now we have the crown here that is all made of wax, right? And it's connected here. You'll see. It is too far. Gases may not escape rapidly enough to permit complete filling of the mold with the void. To provide adequate multiple void during solidification, this screw itself should bring the surface tension reducing agent material against. What they're going to do, they're going to pour that in. So they put that in there, right? And they just put a cover for it around it, and they're going to pour that with plaster or stone, which we call investing. So they're going just to mix plaster, as you can see here. This is a mixing machine with a vacuum into it for plaster. And now they're pouring the plaster into the mold that we have, right? This is called an investing. The procedure is called an investing procedure. So we have the wax pattern there, and then we're just pouring it with plaster. I guess just so that it doesn't have bubbles and make sure that it covers everything in a right manner. That's what they were saying. So that everything is covered. The investment material at the top of the investment frame will normally have a smooth glazed appearance. This must be scraped with a sharp knife to create slightly roughened porous surface. This allows
For an easier escape of gases during both the burnout and casting procedures, the crucible former is then removed.
So now we remove that part, and you can see we have a cone shape. And here, the wax is connected where? Down to the crown, right? So the crown is inside of here, and there is a wax part that is coming out. What we will do, we'll put this in a hot oven that will evaporate all of the wax inside. It's too hot that it will evaporate the wax. The wax will not be found anymore. So what we will have left in there? A space, right? An empty space of wax. We will put a metal inside. We will melt a metal, and we will shoot it into that space, the empty space, and this would form the crown. Again, you will see that. So we have that now. You'll see they will take it out and put it in an oven. Burnout.
Prepare the mold for the molten wood and allows thermal expansion to occur. This is done by placing the ring in the burnout oven and heating it slowly to the casting temperature for about 1 hour. The ring should be set crater up about 10 minutes before the casting is made. This allows oxygen to contact the internal area of the mold to ensure complete wax residue elimination. The mold is now ready for casting. In this video, an induction centrifugal casting machine is used.
So this is the device that they use. You'll see it will run fast, that it will shoot the metal out of here into the part.
The crucible is placed in bracket on the arm of the casting machine. The casting below is placed in the crucible. Enough bulk of metal must be used in casting.
So this is the metal that we're going to use for casting.
And part of the crucible format to ensure sharp and complete detail in casting.
It will start heating up where it's starting to melt. You see, this is the metal. It's going to start to melt in a little bit. There you go.
No more than 30 seconds should be allowed to elapse between the time the ring is removed from the oven. And
now we're taking our model with all of the wax gone out of it.
Any undue delay will cause the loss and result in mold.
And they put it in here. So this is the metal that is melting. And this is the empty space that we did with the wax. What happened, this would run quick like a centrifuge. And the metal will start shooting out from the melting part to the crown part, where it will start putting in there and will form the crown.
Contraction. The mold is placed in the cradle of the casting machine. The machine is
see, it's running around.
Has slowed enough that it can be popped by hand, and the ring is removed with casting tongue.
You see the metal there now?
After the red flow has disappeared from the bottom, the casting ring is plunged under running cold water. Burning is done for the bottom of the ring.
And there you have it. That's the crown.
The casting should appear smooth with a dull dark outside.
Did that make sense? Yeah? It's a lot of work. That's what the lab does. But again, now with all of these machines, 3D printing metals, and then, milling, you don't really have to do this. But still, there are still people doing that. So now they're just cleaning it up. Now it's a little bit more clean. It's still connected to that sprue. They're going to finish it, and you'll see how it will look like at the end. It looks really nice.
A 1.5-inch diameter cutout disc is used to remove the screws. The contouring of the surfaces where the screws were attached is completed with a number 8 aluminum size quarter wheel on the counter.
So you see now this is the crown. They're just going to do a lot of finishing to it.
Part of the work is the family work that everywhere else for the users in its film with a number 1 carbon group.
And make it look nice with all these burrs and finishing things and polishing in it.
The casting is smooth with glue rubber wheels and mounting points.
There you have it. Right? So that was just a wax that we made. We burned it out and then we cast it in and we made a crown out of it. This is if we're making a full crown, a full metal crown, right? So everything is metal into it. If we are making a porcelain infused to metal, we'll make only what we call a coping, which is the part, a metal part that they will start building on. Um, let me see if I have. Think this just to show you. So this is a porcelain. This is how they build porcelain crowns. And this is the porcelain material. They mix it up and they start, the technician, the lab technician will start building it up. I just want to see if they have that um, metal part that is on the tooth that we call coping. So this is the, let's see, this is the tooth, right? And it has the coping metal on top of it. You don't see that clear, but it doesn't have the anatomy. It's just have a metal thing that is on top of it. And now they're still start building it layer by layer. That's what the lab technician must do, and do all of the anatomy of the tooth by building it a little bit by a little bit. You see, this is all, again, porcelain. So they're putting layers, making it nice. And keep building, building, making sure that occlusion is correct, right? That's why we send the bite registration, right? So they can mount it and check the occlusion. They keep building it, building it, building it. Keep going at it. They're adding different layers for different shades. Well, there are different layers that you put. You put first, what do you call an opaque layer, which we'll talk about, to so they would not you will not see the metal part of it. And then you put a body or dentin layer, technically, and then the last layer, which is a little bit more clear, just like enamel layer. Yeah. And you see that all work is done by the lab technician. They have to put all of the anatomy and all of that. Let's see, they're going to remove the dye out of the cast. You see how they have it cut? There it go. They removed it. Now they're going to remove the crown so they can work on it separately. You see it has the metal part on the bottom, and then they just keep building it up and again and more and more and more until they make, this is the metal part, which is the coping that was done by the lost wax technique. They finish it, they make it look pretty, and they fire it under an oven. When we say fire it, that means to heat it up to a really high temperature. And there it is. That's a porcelain fused to metal crown. They'll take it out, I think. Well, they didn't show us, but that's a porcelain metal, it's a fused to metal. So hopefully this kind of got you a better idea about how all of that is done and what we mean by the lost wax technique. When we talk about the metal, about the restoration, if we have, not a prosthesis like a restoration, if it was in the crown, we call it an inlay, exactly. And if it was out of the crown or onlay, as long as you know the main difference between inlay and onlay, I think we did talk about that. Right, onlay covers, exactly. Onlays, I think we did talk about it before somehow, But yeah, onlay covers a cusp. When you have a missing cusp out of the tooth and you replace it, that's an onlay. So this is not a filling. This is, we take an impression, we send it to the lab. The lab would fabricate it with a lost wax technique or 3D printing or milling, any way of these. And that's a crown. So this is just to see, you know, inlay is inside, onlay covering at least one, replacing at least one cusp, and a crown more than one cusp. Anyway, so if we want to summarize the lost wax technique, right? So it's a technique to fabricate metal base restoration. So we first create a wax pattern of the tooth. We encase it in plaster or stone, right? And then we, better word, yeah, vaporize, yeah, evaporate, vaporize, burn out, wax, right? Where we will have an empty space left, and then metal is placed into the space. If you see the pictures next to it, and let's get everyone to fill that out, and then we will see the pictures next to it. Again, that makes it just simpler. You see, we make the wax pattern here. We do it in a sprue, just like we saw in the investing. So this is the plaster part. Let me see here. So we do a wax pattern. We invest it in with a stone, and then we do the burnouts, which there, right? We burn it out, and then we do the casting, right? That's what we watched on the video. Hopefully this is now clearer. It's just, again, the way that is done. Still done for a lot of things. Because, again, even if the crowns nowadays are made with milling, but for example, partial dentures, a lot of times still made of um, wax, and they need to do it that way. I just want to show you just a quick part of this video just to show you how it looked like. So this is
This video demonstrates the screwing.
this is the partial denture, all made in wax. You see that? And they do exactly, then they do exactly the same thing. So they have to put it in a container, you see, and they will pour it with stone. They poured it here. They burn it out. They put it in the machine, right? And then they will take it out and break it down, and you'll see we'll have all of that in metal, and then they will cut it off, polish it, and you'll have a partial denture framework ready for work. See, that's the partial denture that we made with wax. By the way, some of the jewelries are made the same way. You know, the like the metal parts of the jewelry, so they make it with wax and then they burn it out and they do the same thing. So, huh? I I think so, because we did talk about lost wax technique. I think I did have that video also there. But you know, just since we were talking about the same thing. Anyway, these are 3D printing and milling. We'll see these maybe later. Anyway, moving on. Just to show you, this is what an onlay would look like on real tooth. You see how this is technically an inlay almost, because you're not replacing a crown. This is an onlay because you can see it's replacing multiple crowns. It's not a crown made on the tooth, right? It's just an onlay because we're not replacing the whole thing. We're only replacing some cusps of it. We have some of these also what we call 3/4 crowns, which will cover all of the tooth except the buccal part of the tooth. You see the buccal part is still remaining the same thing. It's only the other parts. These are not much done nowadays, but again, it's kind of part of the onlay thing. Okay, now let's talk about these metals that we use to actually do the lost wax technique. So metal, if we talk about restorative and corrective dentistry. It's the most used material, again, because we use it a lot with crowns. We use it with, um, for example, even orthodontics, right? All of these wires are considered metals. We use it with partial dentures, complete dentures. So metal is all there. We don't use metals right away just as pure. We always use them as an alloy, right? Which is a combination of two or more, because this would provide us with better qualities of the metals that will make them withstand the oral environment. So the metals that we use with the lost wax technique, we call them dental casting alloys. The alloys that we use with that technique, we call them dental casting alloys because we cast the material with them. So just some terms to understand. Okay, when we talk about these alloys, they're either made from noble metals or base metals. So we have two types of metals based on would they tarnish or corrode. So noble metals will not tarnish, and base metals, they might tarnish more. So for noble metals, you think, what are they? Gold is one. Silver is not considered as much as considered as a precious. Yeah, because it's still can. Platinum and palladium, right? So again, you'll see the alloys will be classified based on how much noble metals they have. So when you do charting, you'll see that later on, maybe next semester when we do it, especially in Canvas, you'll have high noble metal or base noble metal. So each one of them would charge differently, right? Because high noble metal would be more expensive compared to base metals. And then you have base metals, which you think are what else? Copper, zinc, nickel, right? Titanium. Again, this is when we talk about these because they would not, noble would not tarnish or corrode easily in the oral cavity compared to the base metals. Yeah, yeah. Well, it's not considered as you'll see. I have we call it a precious metal, but it's not a noble metal. Yeah, see those? All these are noble metals. They dress up and everything. No. Well, I know they added more than the ones that we have, but anyway, we're good on that, right? Okay. So let's go into the alloys, the casting alloys that we use in dentistry. So we have three types of them. We have high noble alloys, we have noble alloys, and we have base metal alloys. So high noble alloys would have at least by weight noble metals. 60% by weight noble metals, and at least out of this 60% we have to have 40% of that should be gold. Okay, again, this is just classifying based on how much noble metals are there in them. Then when you're making a crown and you ask the lab to make a crown for you and you say, I want a high noble metal crown that you make for me. So when they make it, they have to have at least 60% noble metals, which can be gold, platinum, palladium, right? But gold has to be at least 40% out of this 60%. If you request a noble alloy crown, for example, it has to have at least 25 noble and does not require any gold into it. Still noble, but no gold, but not high noble, right? The one that is base, less than 25, and definitely do not require gold as well. So again, this is just a classification that we made based on the content of the, based on the content of the noble metals that we use within these alloys to make the crowns or to make the partial denture framework and all of that. Okay, so three different classification: high noble, noble, and base. And again, we should know how much gold percentage for each one and how much noble percentage for each one. So starting with the noble metals that we mentioned, which are three, right? So we're starting with gold now, and we'll talk about small things about it. So we have gold is the most corrosion resistant noble metal. When we measure the content of gold, we can measure it by carats. And that's why I put carats here. Person is. And you know the song? Yes, that's what we're talking about here, carats. Because pure gold is 24 carats, right? Yes. You know the music. So just going back here, because I jumped that, fineness is actually, or fineness is actually percentage multiplied by 10. So when we talk again about the content here, classify it by content. If we say it's a pure gold, so what is the percentage? What is out of 100? A pure gold is 100 out of 100. And what is, and how fine it is? Number 1,000. Yes. Super fine. Right? Because we said fine is the percentage multiplied by 10. So we can say a pure gold is, when we say 24 karat gold, we know that this is pure gold. Or when we say 100% gold, we know that's a pure gold. Or when we say a 1,000 fine gold, we know that it's pure gold. Makes sense, right? Just a way of measuring it. So when it's half gold, it's 12, right? 12 carats, right? Half, or 50%, or 500 fine. Exactly. Okay, makes sense. So that's what gold is about. Now, the other noble metals, we're still here working on the noble metals. We have palladium and we have platinum. Palladium is used because it's good corrosion resistant, increased hardness of the alloy, and it's less expensive than gold. While platinum is not used much because it's more expensive and have high melting point and difficult to mix with gold. Okay. Silver, on the other hand, is considered as precious. It is not noble because of its tarnish and corrosion in the oral cavity. Don't break that keyboard. Okay, guys. So we're done with the noble metals that are used in the casting alloys. Now we'll talk about the base metals. So for the base metals, we know that the alloys that are made from base metals consist less than 25%, which we'll talk about up here already, right? That is the 25%. And just a reminder, these are our base metals: copper, nickel, silver, consider also zinc, tin, and titanium. Going down here. I think I forgot to mention something here. But anyway. So the most common alloy that we have is either chrome cobalt or nickel chrome. That's usually used to make the framework for these partial dentures. So chromium provide corrosion resistance and require higher temperature, casting temperature. I mean, generally the metal alloys as well, the base metal alloys require higher casting temperature. Some of them have some biocompatible problems. That's what I think. I had a slide, I think I deleted. I wanted to add at least few things out of it. I think with zinc. Zinc, so like women are more uh, have more sensitivity to zinc than men. And they were saying that because they wear jewelries that might have zinc in them, and that will that exposed them to more zinc allergies. Think something like that. I need to go back to that slide and see it. But yeah, I remember that was a point there. It's just few. I think again, it's the same thing, but let me check that. I'll check that and let you know, guys, if I need to add it. Anyway, what do we have here? So the stiffness of these metal alloys, you think it's more or less than gold-based alloys? More? How much more? Twice. So they are more stiff compared to gold-based alloys. So when we compare them to noble metal alloys, the ones that are base metal alloys, they're actually twice stiff as gold alloys. And they are useful for removal partial denture. What do we call this part of the? Do you guys talk about removal partial dentures or anything like that yet? Now, next semester, I think. This part of the partial denture is called framework. You see that? This is where we're going to place the teeth. This is before placing the teeth. This is a partial denture, replacing these teeth and this tooth here. So the part where the teeth will fit on later on, which we will build on, we call it a framework. So it is good for the denture framework. And when we talk about stiffness, we know we're talking about the modulus or elastic modulus. So the higher the elastic modulus, the stiffer the alloy, right? So it's the modulus that stiffness is technically the elastic modulus. The more stiff, the more the elastic modulus, or the more the elastic modulus, the more stiff is the alloy. Anyway, so that's the base metal alloys. These are the base metal alloys. We have another type of alloys in dentistry that are similar to the ones that we talked about, but they're made a little bit different so that they can bond to porcelain, right? Were we talking about porcelain fused to metal crowns, right? Which they have a metal portion, which you can see here. That's the metal portion, or that's the metal portion. And then we build it up with porcelain. That's how it looked like, actually. That's how the crown. And if you see it in X-ray, should have put an X-ray here. But in X-ray, it will show you the metal part, and sometimes you not see any of the porcelain part of it, because with the metal you can see it in X-ray. Anyway, so we made alloys that are porcelain bonding alloys, similar to the other ones. Few differences. They're more compatible with, guess what? Porcelain, right? So they can bond better with porcelain, and they will stand higher temperatures because the porcelain would be fired, which means heated up at higher temperature. So we need metals that will stand higher temperature than the regular ones. And they do not expand greatly as well because, again, you have a brittle porcelain on top of them. And if they expand too much, then they can break it, especially when we are firing it up. If you remember, we were seeing that video just now. They build up the porcelain on top of that coping, and then they put it in the oven where they fire it up in high temperature. And that's why we make alloys that will work better with porcelain, and they will stand high temperature. They will not expand too much and break it, and that's what they make. So when we talk about the porcelain fused to metal, because that's the main thing that we make these metal alloys for, the metal part is called coping. Yes, right? This is what I was talking about. The coping is this metal part that resembles the tooth, but without any anatomical landmarks. It's just the part that will fit on the tooth. And again, you can see it here. That's the metal. There's the metal there. It has to be at least zero point 0.3 milliliters, the thickness of it. And then we have the porcelain that will be on top of it has to be at least 1.5 thickness in the functional areas. So if you compare a porcelain fused to metal to an all metal crown, this porcelain fused to metal, we need to reduce the tooth more to allow that thickness of the porcelain. Make sense? Right? Because you need all of that thickness. See how much thickness we need here? So we need a lot of reduction more compared if we do just a metal one, just like we saw in the video, the metal one would require much less. Maybe, about zero point 0.5 milliliters only of thickness. So you don't have to drill the tooth too much to make space for the crown because again, the metal would withstand much more occlusal loads with less thicknesses. Make sense? Okay. So when we're talking about that, when we're talking about the metal, the porcelain fused to metal, again, the way that we're actually doing it, again, as we saw in the video, technically they're layer it, right? So the first layer that will go onto the coping. So see, this is the metal coping that you see in here. That's the tooth. This is the metal coping in black, right? The first layer that goes in there, we call it an opaque porcelain. So why we make this opaque porcelain layer? This would, huh? So you don't see the metal, right? So the metal is there, and because the metal is kind of dark, silvery, so we need something to completely hide the color of the metal. So we make porcelain that is really opaque, that would not be able to see through. That is to prevent us, or to prevent the showing of the color of the coping through the porcelain. Then what we do, we fire it, which means heating it up in the oven. We take it out, and then we add two more layers to it, which are the body and the incisal. Sometimes they call it enamel part. And these are the ones that will make up the tooth shape or color also. And again, you can see it in the picture here. So we have the metal coping, we have the opaque part, and then you have the body, right? And then you have the incisal, and here in this picture, they call the enamel. So it's multiple layers, again, of making a porcelain fused to fused to metal. Again, to understand the way that they're done, because we still make these in offices and we send them to the lab, but we need to understand the process. As we saw, we take an impression, we send it to the lab. The lab would fabricate a wax part of it to make the coping, and then they would start layering it as we saw in the video. And the first layer would be the opaque one. And then the second layer and the third layer will be the body and the incisal, and then they will fire it up. That last firing that we will make, which we call it a glazing firing, which will give the glazing factor of the crown, and technically it'll make it smooth, shiny surface. That's the glazing process, which is the last firing that we do, which the last heating up. Again, we saw that in the video. They put it in the oven, they fire it up, and it comes up looking exactly like a normal tooth with all the shininess and smoothness of the tooth. All good? Yes? So we talked about these that we use for porcelain fused to metal. We talked about the actual porcelain fused to metal crown and what it's made of and how they layer it. Now let's talk about the margin of the porcelain fused to metal that will fit on the tooth. So we have three types of margins. We have a porcelain margin, we have a disappearing margin, and we have all metal margin. So this is when you look at the tooth again, like when you look at these here, you see there is on some of them, for example, this one, we still have a metal margin on the bottom, right? Even with this one, because the metal margin will fit a little bit better. Like for example, here they didn't leave any metal margin. That's all the porcelain. This is what we're talking about here. The ending, how we're making it, or actually how the lab would fabricate it, and we can tell the lab technician how we want it to be made. So this is how, again, the porcelain fused to metal would sit on the crown. So a porcelain that is the most aesthetic, the metal, you will not see the metal out of the patient mouth. You will not see that part extending. So where's that porcelain edge? You can see this is the tooth. We only see the porcelain, so we're not seeing. That happens for some people. You will see when they smile, there's a little bit of a line, a silver line or a metal line on top of their crowns, and you can figure out this is a porcelain fused to metal. But again, if they made it all porcelain, but you'll see how much thickness they need or width of the tooth to actually make it an all porcelain crown when the dentist is preparing the tooth. The disappearing metal, this is a thin knife edge like extend to the margin. You can see we don't need to prepare the tooth a lot. We don't have to make a base. It's just the metal sitting on the tooth. And then you have an all metal. Did I wind up correctly? Yeah, that's the all metal one. To provide the best fits, because it's the only metal, and only when we don't have aesthetic zones. So, again, because we don't want to see the metal appearing on the patient tooth, but this is the best way. So if we have a posterior tooth that would not appear when you smile or open your mouth much, right, we can make the metal margin of it. Again, this is just to show you how it can be. So this can be, again, this is the tooth, this is the porcelain fused to metal crown. We can make it as either all porcelain, right, or all metal finishing on here, or maybe a metal and some porcelain. Again, this is just, and yeah, this is the picture I was looking for. So you can see here how the metal part is showing out of the tooth. This is non-aesthetic area, so we can still make that, again, because nobody kind of going to see it if you don't smile too wide, right? But again, it is a better fit. So when we send that to the lab technician, we tell them, the dentist would tell them, well, I want the margin on the buccal side to be this way and on the lingual side to be that way. And this would, again, depends. If the dentist choose that, they have to prepare the tooth differently, because each tooth preparation is different based on the margin that you want, right? Like if it's all porcelain, you have to make a better shoulder on the tooth. If it's metal, then you don't need much, and so on and so forth. So the dentists have to worry about preparing the tooth and then choosing the right margin for the crown. And last but not least, we have just 2 more slides to go. Since, again, we're still talking about metals in dentistry, we'll talk about solders. So these are the metals that are joined by one of these 3 processes, and you can try to figure them out. Soldering, brazing, and welding. What do you think? Yeah, that is right. So soldering, when you connect 2 metals with another metal, right? So you have a metal filler that required. Welding, when you fuse them without a metal filler, so you just make them melt into each other. And brazing, that is with a metal filler but at high temperature than soldering. Okay, these are just the 3 ways that we connect metals in dentistry. So we have gold and silver solders, which are gold and silver. The gold solders are used for crowns and bridges. So when you have a crown or bridge and you want to connect them together, you use gold. And then silver is used in orthodontics if we want to make different kind of appliances, you connect them together. And that's what we're talking about. Like this is a filler. So if they want to solder the metal and using soldering, you'll need a filler to actually fill it in. Welding, you just melt two metals on each other and there'll be one. So let's see here. And the last are wrought metal alloys. And these are the ones that are extruded or pressed to desired shape. So this was an animated picture, but it doesn't show here because we're not on PowerPoint. But anyway, I mean, you put the metal through something that will press it, and you can make the gauge smaller as it goes out. Applications for crowns, for endodontic files and reamers, and orthodontics, definitely for when we talk about orthodontics, it's mainly stainless steel. And this is to make the stainless steel wires that we use in orthodontics. When we talk about that, especially about wrought metals, again, because they're extruded or pulled, we talk about the gauge, which is the diameter of the wire. The thicker the wire, huh? Yes, the gauge is, which means an 8 gauge is thicker than a 16. And you know why? You know why it's more. The more the number, the thinner the wire, because technically the number is how many times they pull it through, right? So the more you pull it through the machine, the smaller it gets. You're pulling and you're pulling and you're pulling, right? It gets smaller and smaller. The less that you pull through the machine, then means it's still thicker. That's why the number is that way. Any questions, concerns, ideas? Huh? A pink one? Huh? This one left? What is it? Gold. Rose gold. Tried to make a good face. Yay, we're done with materials. How sparkly it is. And that's me having my hair cut. Okay, well, any questions? No, we're good. And let's stop this. I might show you just a one more video. So just